Welcome to today's class. We are going to look at the gradient and intercept of a straight line equation. This is a concept of finding the gradient and the intercept of a straight line without plotting the graph. So, what does that mean? I might be given a straight line equation, okay? I will be asked to find the gradient of that straight line and the intercept, whether at the x-axis or at the y-axis. I don't need to plot the graph to be able to find that uh, gradient and the intercept. So in such situation, what are we going to do? Meanwhile, let me explain the concept of gradient and intercept of a straight line. When you have a straight line graph of this nature, okay, so you plot your straight line graph of this nature. Let's say, for example, this is your straight line. So let's take it as y equals to mx plus c. So this is your straight line. At this point is the intercept on y-axis. Y at this point is the intercept on the x-axis. Then, when you want to find the gradient of a straight line in a graph, you are supposed to pick two points on the line. So those 2 points will give you your x1, your y1, and your x2 and your y2. Remember, any point on the Cartesian plane is a coordinate of x and y. Okay, so when you pick any 2 points, you now find your gradient as m equals to y2 minus y1 over s2 minus x1. Okay, but in this class today, we are not going to look at trying to plot this graph, trying to see where it will intercept on the y-axis, checking where it will intercept on the x-axis, trying to solve our gradient. This time around, with just the equation, we can be able to find the intercept on the x-axis, the intercept on the y-axis, and the gradient without solving this huge equation here or without plotting any form of graph. So let us see how we can be able to do that. Generally, a straight line equation is given by y equals to ms plus c. Okay, so generally this is the equation of a straight line. So we need to analyze this equation. You have y equals to mx plus c. This m here is the gradient of the line, while the c here is the intercept on y-axis. Now you can see that when immediately you can be able to form your equation to look like this. What does that mean? Making y subject of the formula. Immediately you can be able to make y subject of the formula. The number you see attached to s is your gradient. The number that you see that is standing alone, which is the constant, is the intercept on y-axis. So the three problems we are going to solve here, you have already solved two. Immediately you'll be able to express your question or your equation in this form. Okay, then we will now look at how can you now find the intercept on the x-axis. Okay, so we are going to solve a simple example. Then, so we are going to find the gradient, the intercept on y-axis, the intercept on x-axis of the following equations. So number one problem we are going to solve is a very simple one. You can see that it's already expressed as a form of a straight line equation. So we are going to look at how we can be able to find all these three things, which are the gradient and the intercept of this particular equation. So let us solve that now. If you recall that y equals to ms plus c is the general form of a straight line equation, then you compare it with this, which is y equals to 3s minus 5. So it is obvious that m is equals to what? 3, while c is equals to what? Minus 5. Why? Because m is the coefficient of s. Here, 3 is the coefficient of s. That makes m equal to 3. And c is the constant, that's the number without any variable. That makes minus 5 our c. So without even solving anything, we can see that our gradient is equals to 3, while the intercept on the y-axis is equals to what? 5. So we say that's our gradient, and that's our what? Intercept on y-axis. Now, where students most of the time have issue in this is trying to find the intercept on the y-axis. So how do we solve for intercept on the y-axis? Now, before I talk about how we solve intercept on the y-axis, on the x-axis, sorry, is there any other way of finding the intercept on y-axis? Yes. In a simple equation of y equals to ms plus c, the value of x when the value of s when y equal to 0 is the what? Intercept. Intercept on x-axis. Also, the value of y when x equal to 0 is intercept on y-axis. So what does that mean? If I have an equation, if I have this as our equation, we know the gradient is the coefficient of x there. So when you make y 0 and you solve for x, the value you obtain is the intercept on x-axis. That is where the straight line is going to cut the x-axis. And when you make y equal to s equal to 0, sorry, when you make s equal to 0, the value you obtain for the y is the intercept on y-axis. Now, we have already gotten an intercept on y-axis here, which is minus 5. But let us use this concept to still solve for intercept on the y-axis. So with our equation, which is y equals to 3s minus 5, we say that the value of y when s equals to 0 is the what? Intercept on the y-axis. So let us apply that in this equation and see what we get. So if s equal to 0, therefore y equals to 3 into 0 minus 5. Y equals to 5. I think that I have confirmed this. Because when s equals to 0 in a straight line, the value you obtain as your y is the intercept on what? Y-axis. So if y equal to 0, when you put y equal to 0 there, you are going to have 0 equals to 3s minus 5. So that will give us that 5 is equals to 3s. That's when I take this minus 5 over to this place, it change to plus. So when you divide both sides by 3, you have 5 over 3 equals to 3s over 3. 3 will cancel 3 here. I have x remaining equal to 5 over 3. So 5 over 3 is the what? Intercept on x axis. So I can come here and write it that um, 5 over 3 is the intercept on x axis. So that's how we are going to solve that, and that's how to solve any problem of that nature. Just make y subject of the formula. When you make y subject of the formula, the number that is attached to s, which is the coefficient of s, is the gradient of that straight line. And when you make s equal to 0, the value you obtain as your y is your what? Your y intercept. And when you make y equal to 0, the value you obtain as your s is the what? Intercept on x-axis. So we are just going to solve one more problem on that. I think even just this example have been able to explain how to find the gradient, the intercept on y-axis, the intercept on x-axis of a straight line. But let us solve one more problem, probably the one that is not as simple as this, okay, and see what we are going to do. Look at this example. We have 3x over 2 minus 4y over 5 equals to minus 2 over 7. So we are trying to find the gradient, the intercept on y-axis, the intercept on what? X-axis. Remember what I said in the previous example? We need to make our y subject of the formula so that it can be of the form y equals to mx plus c. This is the general form of a straight line equation. So, but this one, you can see there is a lot of numbers that is not arranged like that. So our job here is to make sure that we can be able to make this equation to look like this. So let us start. We need to have our y on one side of the equation. So we're going to carry this one here over here and bring this one here over here. So that will give us 3s over 2 minus 2 over 7 will cross over to become plus 2 over 7 equals to 4y over 5. So we have 4y over 5. Now I need to remove this 4 over 5. So what am I going to do? Watch here. If I have 4 over 5, I need to remove it. All I need to do is to multiply by 5 over 4. So that this one and this one will cancel. This one and this one will cancel. That will give me 1. Okay, so for me to remove 4 over 5, I can multiply by what? 5 over 4. So how will you do that? You multiply by 5 over 4 here, multiply 5 over 4 here, multiply by 5 over 4 here. But remember, that is not the only way you can remove 4 over 5. You can first of all multiply by the LCM of 2, 7, and 5. That will first eliminate the fractions. Okay, so when you remove the fractions, you now divide by the coefficient of y in order to remove the number that is attached to y. So what it means is that you have multiplied first by 5, then you have divided next by what? 4. So that's the same thing with multiplying by 5 over 4. So whichever method you decide to use, you are still going to have the same answer. So I'm going to use the LCM to multiply. Okay, so I think that one is a little bit more common. So let us multiply by the LCM. Like we did in LCM, if you have not watched videos on LCM, on algebraic fraction, on factorization of algebraic expressions, please, I will encourage you to go and watch those videos because you need to have an in-depth knowledge on LCM, HCF, LCM of algebraic expression, HCF of algebraic expression, factorization of algebraic expression, simplification of algebraic expression. All those things are basic knowledge in maths because most of these things, as you move advanced, most of the problems, you will always encounter an algebraic expression, which is very important. Okay, so I'm going to advise you and encourage you to move back to those videos and watch them and try to solve, for example, to refresh your memory on those topics. Okay, so in one of the videos I have there, I showed you that when you have LCM of numbers that does not have any factor, any common factor, all you need to do is to multiply the number. So I don't need to start thinking of, well, how am I going to multiply? How am I going to get the LCM? Since there's no common factor, 2 times this, that's my LCM. So my LCM there is 2 times 7, which is 14. 14 times 5, which is 70. So I'm going to use 70 to multiply this, 70 to multiply this, and 70 to multiply this. So that will give me 70 into 3x over 2 plus 70 into 2 over 7 equal to 70 into 4y over 5. Remember, there are other methods. There are so many methods you can use to make your y subject of the formula. So 2 here will give me 35. 7 here, 7 here will give me 10. 5 here will give me 14. Okay, so when you multiply 35 times, that will give me 105x plus 20 equal to this, and this will give me 56y. So let's divide all through by 56 in order to have our y alone. So that will give me 105x over 56 plus 20 over 56 equals to 56y over 56. Okay, so this and this will go. I'll have y left equal to, let's start from here. 7 here will give me 8. 7 here will give me 15. So that will give me 15 over 8x. 2 here will give me 10. 2 here will give me 28. 2 here will give me 5. 2 here will give me 14. Okay, so that will give me plus 5 over 14. Now, had it been that we multiply by 5 over 4, 5 over 4 here will give us 5 times this will give us 10, 4 times this will give us 28, which you can still divide. Okay, 5 over 4 here, it will still give us the same value there. So we have expressed this equation like this now. Okay, so without solving anything, we can get our gradient as what? 15 over 8. Okay, then we can have our intercept on y-axis as 5 over 14. So the next thing now is to solve for intercept on x-axis. And how do we solve intercept on x-axis? That is by making y equal to 0. Then we now find the value of x. So let's say let y equal to 0. So for y equal to 0, I'll have that 0 equal to 15x over 8 plus 5 over 4. So that will give us that 15s over 8 crossing over. These have to cross over to give us minus 5 over 4. Now, what have happened is that I carry this one here over here. Okay, both of them are positive. So for one to be on one part of the equation, one of them have to be negative. So I choose this to be negative. I can equally put my negative here and leave this one as positive. Then after that, transfer the or divide all through by minus 1. So with what I have now, you cross and multiply. So when you cross and multiply, you have that 15s, this one coming over there, equal to minus 5 times 8 over 4. Okay, so 4 here will give me 1, 4 here will give me 2. So I have that 15s equal to minus 10. Okay, so when you divide both sides by, let me manage this space. Okay, when you divide both sides by 15, 15 here, 15 here, this and this will go. I'll have s equal to 5 here, 2, 5 here, 3. So that will give us minus 2 over 3. Therefore, the intercept now, the intercept on y-axis, the intercept on x-axis, not y-axis, on x-axis is equal to minus 2 over 3. So that's our answer there. So you can see that though is a little bit longer than the previous question, but the concept remains the same. So first of all, any kind of equation given to you, so long as it's a straight line equation, make it to look like this. Okay, make it to be in this form. When you make it to be in this form, you have gotten your gradient and your intercept. That is the value as of the coefficient of x and the constant. That's your gradient and the what intercept on the y-axis respectively. Then you make y substitute of the formula. The value you obtain as your s is actually the s intercept on the x-axis. Okay, so that's where we are going to end this class on gradient and intercept of a straight line equation.